All right, can everybody see my slides okay?
Yep.
Okay, so it's nice to see a couple new faces. Welcome to the SAM Lab, you guys. For those of you that don't know me, my name is Shannon. I'm a PRA in the lab. I graduated from CU Boulder last May with my master's, and I worked in our sister sleep lab there for about 4 years. So graduated, moved back to Fort Collins. I'm from here, and I'm currently applying and interviewing for medical school right now. And I am happy to be a part of the SAM Lab here at CSU. So today I'm going to be presenting a paper titled Physiological Sleep Tendency and Ability to Maintain Alertness at Night by Jeffrey Sugarman and James Walsh. It is a pretty old paper. It was published in 1989. But really I want to focus on MWT versus an MSLT. And I'll describe what these tests are on the next slide, but really these are objective measures of sleepiness. So a lot of you guys are probably familiar with the KSS, the Karolinska Sleepiness Scale that we use in our current studies. For those of you that aren't, it's just a scale of 1 to 9, with 1 being I'm not sleepy at all and 9 being I'm super sleepy, really struggling to stay awake right now. And that's really a subjective measure of sleepiness where people can rate how sleepy they're feeling in that moment. And so the MWT and the MSLT are really objective measures of sleepiness. So this paper really talks about kind of what the tests are and compares them, kind of talks about when you would choose one test over the other. So what are these tests? The MWT stands for Maintenance of Wakefulness Test. So in this test, the participant would be sitting in a comfortable high-backed chair. In our study, they would just be laying in the bed, and we would raise the head of the bed up. They would be in a dimly lit room, and basically they would be instructed to remain awake without any extreme sleep compatible behaviors. So we would ask them, not to clap their hands, not to hum or sing, stomp their feet. You'd be surprised what people try to do to stay awake. And then the MSLT stands for the Multiple Sleep Latency Test. And in this test, participants would be lying down in a bed. They would be in a dark room. Sometimes they'll be in a dimly lit room, but a lot of times you turn the lights out and you instruct them to try to fall asleep. So in the MWT, you want them to remain awake. In the MSLT, you want them to try to fall asleep. Both of these tests last 20 minutes, and really you're measuring sleep onset latency, or the time that it takes a person to fall asleep. And if they don't fall asleep during that 20 minutes, you use a latency of 20 minutes for future analyses. So those are kind of the two different kinds of tests. So looking at this paper, really in 1989, the MSLT was established as the valid measure of physiological sleep tendency. But however, researchers started looking at extreme sleepiness in conditions such as narcolepsy or other sleep pathologies like sleep apnea. And they also started looking at like the marked circadian sleep tendency of the early morning hours. And they were finding that in these conditions, or at these times where people were very vulnerable and very sleepy, that the MSLT had limited sensitivity. And so for those of you who don't know, narcolepsy is characterized by sudden attacks of sleep, and a common symptom is this excessive daytime sleepiness. And it's the same case for sleep apnea. A lot of times individuals are really sleepy during the daytime hours. And during the early morning hours, such as 3 or 4 a.m., individuals have their lowest circadian drive for wakefulness. So a common theme between all of these different conditions is that people are already excessively sleepy. And so researchers started to find, with using the MSLT as a measurement of sleepiness, that as sleep latency, or the time that it's taking individuals to fall asleep, got closer and closer to 0, there was a limit to the rate at which an individual can fall asleep regardless of the intensity of that underlying sleep tendency. And they called this the floor effect. So once again, when the MSLT sleep latencies started getting extremely short, the MSLT really couldn't discriminate among various levels of sleepiness. And a couple studies that looked at this, there's a study done in narcoleptic patients, and basically they were attempting to reduce sleepiness in narcoleptics using a stimulant medication. So here in this table, we're looking at pre-medication versus post-medication in different subjects, and we're really just going to focus on the MSLT data. But basically they found that there were no differences in MSLT sleep onset latencies pre-medication versus post-medication, despite having improvements in subjective sleepiness. So these participants subjectively felt like they were less sleepy, but the MSLT wasn't sensitive enough to kind of display that. And further, there was another study that attempted to decrease sleep tendency in the early morning hours. For example, a shift worker who might take or sleep during the daytime and then work overnight. And so they tried to increase that prior daytime sleep with a benzodiazepine. In this instance, they used triazolam. And what we're looking at here is the different MSLT tests across the x-axis and the minutes to sleep onset and the y-axis. And again, they found that there was no significant change in the sleep onset latency between the placebo condition and the triazolam condition in showing this. And so really these studies are showing that the MSLT might not be sensitive enough to show differences in sleepiness among people that are already excessively sleepy, whether that's due to an underlying condition such as narcolepsy, or whether it's just due to, a certain time where individuals are very vulnerable in their circadian rhythm. And so when researchers started to realize this about the MSLT, they created two other tests. They created the MWT, which I described earlier, and then they also created the RTSW, which is called the Repeated Test of Sustained Wakefulness. Both of these tests are basically the exact same, but in the RTSW, individuals are lying down in the bed and asked to remain awake instead of sitting up in the bed and being asked to remain awake. Now, personally, I had never heard of the RTSW before reading this paper, so I think that maybe the MSLT and the MWT are more common nowadays, but I'll include the RTSW because they did talk about it. And really, those tests are measuring your ability to remain awake versus your ability to fall asleep. So the purpose of this study was to compare the MSLT with the MWT and the RTSW and evaluate differences in sensitivity to variation in physiological sleepiness. So from now on, I color-coded the MSLT in red and the MWT and RTSW in green, just because I know the acronyms can get a little bit confusing. But remember, MSLT is when they are being asked to fall asleep, and the other two tests are when they're being asked to remain awake. So in this study, they recruited 7 young, healthy, normal sleepers. There were 3 females and 4 males with an average age of 21.3 years. All of these participants had regular sleep schedules greater than 7.5 hours per night. They didn't have any medical or sleep conditions. They kept a regular sleep schedule throughout the study. And similar to our studies, they avoided alcohol and naps within 48 hours, and they did not consume any caffeine during their inpatient stay. And the protocol for this study, it was a randomized crossover study. So there were 2 conditions, and all the participants completed both conditions separated by a minimum of 1 week. So very similar to our TRE study. And the conditions were a nap condition and a no nap condition. And these really got at that variation in sleepiness and alertness. So the outcomes they measured were the 3 sleep latency tests. They also did a performance battery. Something funny reading this was that the performance battery was done with pencil and paper. That's how old this study was, whereas nowadays we do it on the computer. And then they also took subjective sleepiness ratings. So if we look at this protocol schedule over here, all of the individuals would arrive to the lab at noon. and they would eat lunch and they would get a PSG hookup. So polysomnography, you attach electrodes to your head, your eye muscles, your chin muscles, and that really allows you to measure wakefulness and different stages of sleep, what they needed to run these sleep latency tests. So in the nap condition, individuals would go to bed at 2, and then they would sleep a minimum of 4 hours or a maximum of 6 hours, basically however long they could sleep. And then they would get up. In the no nap condition, they would complete this afternoon session of testing. So they would complete an MSLT. 30 minutes later, they would complete the MWT and the RTSW. They would have a 30-minute break, and then they would repeat that 2 more times in the afternoon. And then in both conditions, they would eat dinner at 8 o'clock, and then they would start this kind of nighttime schedule of testing, which was a performance test followed by these 3 different sleep latency tests. Does anybody have any questions about the participants or about the protocol, study design, anything like that?
I just curious, Shannon, if did they monitor them prior to the study? So did they know their like incoming sleep debt or sleep situation?
They didn't say anything about that. They said they kept a regular sleep schedule, but they didn't say anything about using an ActiWatch or an ActivePal or call-ins to really monitor that. And I'll kind of talk about that later in the presentation about how that might be a limitation, just because they're using this one schedule and not really going off of their habitual sleep times.
Hey Shannon, I got a quick question.
Yeah.
The MSLT is to determine sleep latency. In like a normal population, do you normally fall asleep in 20 minutes of laying in a dimly lit room? Is that sort of like the baseline?
Sorry, can you repeat your question? You're asking if a healthy, normal population would fall asleep in that 20 minutes?
Yeah.
Yeah, so it really depends on how sleep deprived you are. So oftentimes people don't fall asleep in that 20 minutes, but especially when you're running these tests during the biological night, it is common for people to fall asleep. I think the clinical value for the MSLT is if you're falling asleep in under 5 minutes, then that's clinically significant. That's like you're really sleep deprived at that point. But other than that, yeah, people do tend to fall asleep during that 20 minutes, unless it's like the middle of the day and you're not sleepy at all. So it really depends on the timing of the test and, how sleepy you are at that time. Cool. All right. So then we'll go into the results. Just before I go into these results, I will say that in the no nap condition, when individuals were doing the afternoon session of testing, there were no significant differences in sleep onset latency between the 3 tests in that afternoon session. So all of the data that I'm going to present now is just in that nighttime schedule or that nighttime session. So here we're looking at the 3 different sleep latency tests. You have clock time down on the x-axis, and you have sleep onset latency in minutes on the y-axis. And then you have your 2 conditions, your nap condition and your no nap condition. The nap condition is a solid line with no nap being a dashed line. And the first thing to notice is that there is a significant effect of time across all tests and all conditions. So as it got later and later into the night or earlier and earlier into the morning, individuals were falling asleep quicker. They were more sleepy in all of the tests and through both of the conditions. There was also a significant effect of condition. So if we compare the solid line to the dashed line, individuals that were given the nap opportunity that previous afternoon had a longer sleep latency. So it took them longer to fall asleep in all 3 of the tests compared to the no nap condition. And then lastly, looking at post hoc comparisons, they indicated that the MWT and the RTSW, so the 2 tests where individuals were instructed to stay awake, had longer sleep latencies than the MSLT, which makes sense because this test you're asking people to try to fall asleep, whereas these two tests you're asking people to try to stay awake. Does anybody have any questions on this first figure? Okay, great.
Shannon, before you go on, could you maybe add a little bit more about why the nap, why there's that effective condition, just to kind of what Raj was asking, but talking about that sleep history for people, for new people?
Yeah, so the nap really kind of represents, I don't know if you guys are aware of the two-process model of sleep. There's your circadian drive of wakefulness, but then you also have this homeostatic drive for sleep. And so the nap is really, it's dissipating a lot of sleep pressure that you build up the longer you're awake. And so individuals that are given that nap opportunity dissipate a bunch of that sleep pressure. And so then they wake up after having a 4 to 6 hour nap, and you can imagine they feel more revived even though they're staying awake overnight. They had that nap opportunity to dissipate some of that sleep pressure, whereas the individuals that didn't take a nap are just building up on that sleep pressure. And so that's why they're falling asleep quicker in all three of these tests.
Awesome, thank you. One, just to follow up on that is just a little bit the basics, and we'll have a whole lecture probably on the two-process model, but just as a reminder for new sleep newbies, this idea that the circadian system is anticipatory in nature, but the sleep process is homeostatically driven, just like Shannon mentioned. So you build up a pressure to sleep over time that then is dissipated when you fill that need. Yes, exactly.
This is a really good figure for that. So here you can see that buildup of sleep pressure. I always like to think about it as putting bricks in your backpack the longer you're awake. So you're really building up that weight to wanting to sleep. If this is your consolidated sleep schedule, you can see that that sleep pressure dissipates. But then you also have that circadian drive for wakefulness, which is kind of counteracting that sleep pressure. So it's keeping you awake as that sleep pressure is building up.
Hey, Sharon.
Yeah.
Do naps have any effect on the circadian pressure or the circadian rhythm, or is it pretty much exclusively the brick pressure?
Yeah, so sleep does not affect your circadian rhythm. So I don't know, have you heard of like melatonin and how that's a marker of your circadian rhythm? So melatonin, whether you're awake or you're asleep, will follow the same rhythm. Whereas other things might be sleep driven, but your circadian rhythm will keep the same rhythm regardless of sleeping or being awake.
Great, thank you.
All right.
So I'm going to ask the group, especially new peeps, maybe Kobe, think of what is another system that's homeostatically regulated, similar to sleep, if we had to make a comparison to another behavior or process that you sort of build up over time and then dissipate.
I have no idea if this is right or this is just where my mind is right now, but hunger.
Totally. Yeah, exactly. Hunger is, I mean, it's regulated by a lot of different things, but one of its regulating factors is this homeostatically driven response, because hunger increases over time and then is dissipated with food intake. Anything else you guys can think of? A homeostatically regulated physiological process. Actually can't think of many others.
I know you guys mentioned melatonin, but doesn't cortisol have to do with it too? Doesn't that help promote the wakefulness, your serum cortisol levels?
Cortisol is certainly related. Cortisol can be affected by behaviors like exercise and stress, but it is itself another marker of the central circadian clock. So similar to what Shannon said, if we hold wakefulness constant, cortisol itself will actually have its own circadian rhythm. So it's definitely related to these processes.
I think an example, I think growth hormone is a hormone that is primarily sleep driven, or it's based on sleep wake rather than circadian driven. So growth hormone like increases while you're sleeping, usually, if I remember from my sleep physiology class.
Yes, that's totally accurate. Sleep deprivation significantly reduces and suppresses growth hormone. It's a sleep regulated hormone for sure.
All right. Cool. So this table is looking at average sleep latencies between the 3 different tests, and it's separated by condition, by the nap condition and the no nap condition. And the main thing to focus on here is the RTSW and the MWT, the 2 tests where individuals are instructed to stay awake. There's actually a significant difference in sleep onset latency between the nap condition and the no nap condition. However, in the MSLT, there was not a significant difference in that sleep onset latency. And this really shows that there's a differential impact of prior sleep on staying awake and alert compared to trying to fall asleep. And then the last table in this paper was looking at performance tests and subjective sleepiness ratings. You have your time across the top here, time of night, and then you have your digit symbol substitution task separated by condition, the Wilkinson addition task, and then the Stanford sleepiness scale. And really the main point of this figure is that they found a significant effect of time on the digit symbol substitution task and the Stanford sleepiness scale. So as it gets later and later into the night, individuals are performing worse and worse on this performance task. They didn't find that with the Wilkinson addition task, but then they did find that with the subjective sleepiness, a lower number was less sleepy, and as the night went on, it rose to a larger number, which means that they were more sleepy. They didn't find any significant differences between conditions for any of these 3 parameters. So kind of conclusions from this study. Compared to the MSLT, the RTSW and the MWT appear to be more sensitive to differences in sleepiness and alertness. And in our case, that was driven by that prior nap opportunity. And really this can be explained by the floor effect of the MSLT. So even if sleep tendency was greater in the no nap condition, there was very little room at the bottom of that MSLT scale to really reflect this difference. And then these data confirm potential limitations of the MSLT in populations with high physiological sleep tendency, whether this is because of an underlying condition that makes someone excessively sleepy, or whether it's just because it's a vulnerable time in someone's circadian rhythm, you know, those early morning, overnight, biological nighttime hours. And then lastly, these data also suggest that there's a difference in someone's ability to maintain wakefulness compared to their ability or their tendency to fall asleep based on prior sleep opportunities. So there might be an amount of sleep that's adequate to influence someone's capacity to remain awake, yet it doesn't affect their tendency to fall asleep. And then some kind of strengths and limitations of this study. It is a within subject design, so being a randomized crossover study, you limit some variation that could come from a between subject study. And then their exclusion criteria and study criteria were more strict like our studies are. So they took into account things like alcohol or napping or caffeine, things that could be confounding variables for these outcomes. And then limitations, like Josie mentioned kind of when I was going over the participants and protocol is that they didn't base the study on habitual sleep time. So all the participants came in at noon, all of them ate dinner at 8, and they completed their testing at the same times throughout the night. And you can see that that might be a limitation if you have one participant that's more of an early bird and maybe they usually go to bed at 9 p.m. compared to a participant that might be a night owl and usually goes to bed at 2 or 3 a.m. You can see how that might affect some of, the sleep onset latency values, their performance testing, things like that. And so that's why we base all of our studies on habitual sleep times of our participants. I also thought that the order or the schedule of testing at night might be a limitation in this study. For those of you who have never run an MWT or MSLT or have never seen one, they're not easy tests for participants. If you can imagine sitting in a bed in a dim room just staring at a wall for 20 minutes overnight when you're already extremely tired and trying to stay awake, that continuous schedule, they're basically doing these tests continuously throughout the night. And so you can imagine that might take a toll or have an influence on the outcomes, and whether they're doing an MWT before an MSLT or vice versa, that could also affect the sleep onset latencies or the outcomes of the study. Inconsistent nap times. So like I said, some people only slept for 4 hours while other people slept for 6 hours. Like I said, we were talking about that buildup of sleep pressure. So you could imagine that someone who had a 6-hour nap would probably be less sleepy than someone who had a 4-hour nap. And so just keeping that consistent might have strengthened this protocol. And then they also mentioned that their sample size of 7 participants was extremely small for the correlational analyses that they ran. Do you guys have any other thoughts or ideas on strengths or limitations? I know you guys didn't read the paper, but just based off of what I've presented.
I want to ask you guys, what do you think is true, either about yourself, if that helps you think about it, or if someone else, if you're able to take a 6-hour nap at 2 p.m.? What does that tell you about what else might be going on? What do you think, Corinne?
If you're able to take a 6-hour nap, you probably have your circadian rhythms and stuff is probably off already before even starting the study. I don't think I could take a 6-hour nap in the middle of the day.
Yeah, something's going on, right?
Wrong,
yeah, in your history, maybe, or you were really sleep deprived coming in, right? If they said people had to keep regular sleep habits, that's okay. Kobe has to leave. Bye, Kobe. But yes, exactly. So if someone is able to take even a 4 to 6 hour nap is really uncovering some underlying sleep debt. So that's definitely a confounding factor here, is that people are potentially sleep restricted. In fact, some nap studies will actually on purpose build a sleep debt so that you can assess the nap, because a very, like, if our people who come into any of our studies that we keep on that 9-hour sleep schedule for 1 to 2 weeks before they come in, they are not going to be able to take a 2 p.m. 4 to 6 hour nap. They probably can't even fall asleep at that time. So that really shows that there's potential sleep loss kind of historically as they're coming into the study. Sorry, I don't want to keep rambling. Shannon, if you have more slides.
Oh, no, that's okay. I only have one more slide, so.
Okay. Go ahead. I'll ramble after. This is awesome. Thank you for this presentation, by the way. It's like so good.
Yeah, of course. The last one is really just translating it to our lab and our research. So like I said, we're going to be running MWTs in C2CM, and kind of why we chose MWTs versus MSLTs is that, remember our C2CM.
Oh, wait, don't answer. Don't answer.
Okay.
No, because you're totally, that's the kind of what the rambling I was going to do, is to ask why do you think we are running MWTs in C2CM? What's a case where we might have chosen, so reminder, we're looking at the ability to stay awake. What's a case where we might have actually chosen the other one, with ability to fall asleep? If you guys want to kind of let that percolate around while you're thinking. Actually, if you unshare, Shannon, then I can see how I can, oh, like I see Sophie. I can see when you unmute, that means you're like gonna talk. So if you unshare, Shannon, I will be able to see everybody's mute go on and off. Okay, go ahead, Soph. What did you want to?
Sure. Okay. So I would say that one consideration would be their shift work, or we're simulating shift work, so they need to be awake. So it makes sense to see how difficult it is for them to be awake. And then also, not so much along the same lines, but just based on the data Shannon showed, it seemed like this study might be a little bit more sensitive, which I think might be nice for results.
Yep, exactly right. We are really interested in the ability of the people during simulated shift work to maintain wakefulness, especially in light of our countermeasure. So what's our hypothesis? It's not our primary hypothesis, right? C2CM is really interested in metabolic outcomes, but we have these secondary hypotheses. Do you want to say what, maybe Sophie, follow up since you started? Yeah, and say what you think is our hypothesis for that.
Sure, absolutely. So I would think our hypothesis would be that time-restricted eating in the shift work study would help improve the scores of wakefulness and make these shift workers able to stay awake more on job.
Yep, exactly. Yeah, that's that's one of our secondary hypotheses for this study, and we're also going to get at that with some of our cognitive assessments that Shannon presented a couple weeks ago. So, okay, in the same exact study of C2CM, when might we choose to do the sleep latency, to do a sleep latency test? When might we want to know if people are falling asleep quicker? What else is a problem for shift workers in general in their lives?
Falling asleep in the morning, like once it's light out, when they get off shift.
Yeah, totally. Daytime sleep. Big issue with sleep with shift workers is that not only are they required to stay awake overnight, and they have this huge sleep pressure, and then all of a sudden they can't fall asleep when they need to in the day. So doing some MSLTs during the daytime would be also kind of a cool way to assess whether our countermeasure would improve sleep latency in the day. We can't assess that in this study, because to do that, we actually can't let them fully fall asleep. But one thing, what we can do, what's sort of what we can do in this study if we can't do MSLTs? Sarah, because you're a sleep PSG person, what can we take a peek at to get an idea at this?
Just look at their sleep onset latency when we first allow them to go to bed in the morning.
Yeah, exactly. So we've got PSG on the people. We're looking at their daytime sleep, both sleep onset latency, but also markers of sleep quality. So we could, again, secondarily hypothesize that our overnight no eating condition might improve markers of sleep quality in the daytime sleep. And that's another thing we kind of mentioned in the grant, something we could take a peek at. Okay, so then what study, of course you'll totally know the answer to this, but